Let's use the intermediate value theorem to find intervals of length 1 which contain real zeros of this polynomial function here. So polynomial functions, we know just by the structure of these things that their domain is all the real numbers and that all polynomial functions are smooth and continuous. So we can draw them, if we were going to draw the graph, we could draw the graph, without picking our pencil up off the paper. So the intermediate value theorem, let's just talk about that just a little tiny bit. So we got, this isn't exactly what's written in the textbook, but 241 is the page that this is on. So if we have a continuous function on some interval and we have a less than b, if we find that f of a and f of b, so that is the endpoints of this interval, if we find that they have different signs, then that means that f has to have at least one zero between a and b. Well, how can something be maybe negative here and positive here, and if it's continuous, well, it's got to pass through the x-axis somehow. It might be better to look at a picture here. So if we drew a nice picture, la-di-da, there it is, and here's a polynomial function. Now, if we took our a value here and we took our b value to be here, if we looked at what f of a was, we would have a point here. This is the point a, comma, f of a. And this here point is b, comma, f of b. So we can see that f of a in the picture is bigger than 0, and f of b in the picture is strictly less than 0. So this means that they have different signs, right? So we know that if a polynomial function is positive on one side and negative on the other side, well, it's got to cross through that x-axis at some point. So that's really all that this intermediate value theorem says, and we can go ahead and apply it. And all we really have to do is just crank some numbers through the function here. So we've got our function. I already did this on a separate sheet because this ought to be a routine exercise here to just find, excuse me, moving that around, ought to be a routine to just find these function values, right? We just take each of these x values, plop it into the function. Maybe I could make this more clear that this is our function, right? So we're just, crank the numbers through, we get these values. So what we're really after is where it changes signs. So we can see on this far right column here that it changes signs between these two and between these two and between these two. So that means that there must be a 0 between -3 and -2, right? Because it changes signs. It's negative at -3 and it's positive at -2. Here we have to have a 0 between 0 and 1 because it's positive on the left side and negative on the right side. We say the same thing about this interval here, so that's between 2 and 3. So these are our intervals of interest, and if we're going to go and put our nice solution in the little boxes, we would put a little check mark by that one, we'd put a little check mark by that one, and we put a little check mark by that one, and that's it.